Hello everyone, I'm Tarun Gaud from Data Science, roll number 22951 E67F5, and the subject is data management and representation. And my topic is data cleaning or data cleansing. These are the topics which I covered in the presentation, that are data cleansing or data cleaning, data cleaning and importance, process, quality screens, data cleaning in data science, steps to perform data cleanliness, data cleansing or data cleaning. Data cleansing or data cleaning is the process of detecting and correcting or removing corrupt or inaccurate records from a record set, table, or data set, and refers to identifying incomplete, incorrect, inaccurate, or irrelevant parts of the data and then replacing, modifying, or deleting the dirty or coarse data. Data cleansing may be performed interactively with data wrangling tools or as batch processing through scripting or a data quality firewall. After cleansing, a dataset should be consistent with other similar datasets in the system. The inconsistencies detecting or removing may have been originally caused by user entry errors, by corruption in transmission or storage, or by different data dictionaries definitions of similar entities in different stores. Data cleaning differs from data validation in the validation almost invariable means data is rejected from the system at entry and is performed at the time of entry rather than on batches of data. The actual process of data cleansing may involve removing typographical errors or validating and correcting values against a known list of entities. The validation may be strict, such as rejecting any address that does not have a valid postal code, or with fuzzy or approximate string matching, such as correcting records that partially match existing known records. Someday, cleansing solutions will clean data by cross-checking with a validated dataset. A common data cleansing practice is data enhancement, where data is made more complete by adding related information, for example, pending addresses with any phone numbers related to the addresses. Data cleansing may also involve harmonization or normalization of data, which is the process of bringing together data of varying file formats, naming conventions, and columns, and transforming it into one cohesive dataset. A simple example is the expansion of abbreviations STRD etc. to street, road, etc. Data cleaning and importance. Data cleaning is a crucial step in the machine learning ML pipeline, as it involves identifying and removing any missing, duplicate, or relevant data. The goal of data cleaning is to ensure that the data is accurate, consistent, and free of errors, as incorrect or inconsistent data can negatively impact the performance of machine learning, that is ML model. Professional data scientists usually invest a very large portion of their time in this step because of the belief that better data beats fancier algorithms. Data cleaning, also known as data cleansing or data pre-processing, is a crucial step in the data science pipeline that involves identifying and correcting or removing errors, inconsistencies, and inaccuracies in the data to improve its quality and usability. Data cleaning is essential because the raw data is often noisy, incomplete, and inconsistency, which is negatively impact the accuracy and reliability of the insights derived from it. For decision making, the integrity of the conclusions draw heavily relies on the cleanliness of the underlying data. Without proper data cleaning, inaccuracies, outliers, missing values, and inconsistencies can compromise the validity of analytical results. Moreover, clean data facilitates more effective modeling and pattern recognition as algorithms perform optimally when fed high quality, error free input. Additionally, clean datasets enhance the interpretability of findings, aiding in the formulation of actionable insights. Process data auditing. The data is audited with the use of statistical and database methods to detect anomalies and contradictions. This eventually indicates the characteristics of the anomalies and their locations. Several commercial software packages will let you specify constraints of various kinds using a grammar that conforms to that of standard programming language, example JavaScript or Visual Basic, and then generate code that checks the data for violation of these constraints. This process is referred to below in the bullets: workflow specification and workflow execution. For users who lack access to high-end cleansing software, microcomputer database packages such as Microsoft Access or FileMaker Pro will also let you perform such checks on a constraint by constraint basis interactively with little or no programming required in many cases. Workflow specification: the detection and removal of anomalies are performed by a sequence of operations on the data known as the workflow. It is specified after the process of auditing the data and is crucial in achieving the end product of high quality data. In order to achieve a proper workflow, the causes of the anomalies and errors in the data have to be closely considered. Workflow execution: in this stage, the workflow is executed after its specification is complete and its correctness is verified. The implementation of the workflow should be efficient even on large sets of data, which is inevitable poses a trade-off because the execution of a data cleansing operation can make computationally expensive. Post-processing and controlling: after executing the cleansing workflow, the results are inspected to verify correctness. Data that could not be corrected during the execution of the workflow is manually corrected. If possible, the result is a new cycle in the data cleansing process where the data is audited again to allow the specification of an additional workflow to further cleanse the data by automatic processing. Quality screens: part of the data cleansing system is a set of diagnostic filters known as quality screens. They each implement a test in the data flowchart. If it fails, records an error in the error event schema. Quality screens are divided into three categories. Column screens: these testing the individual columns, example for unexpected values like null values, non-numeric values. They should be numeric out of range values, etc. Structure screens: these are used to test for the integrity of different relationships between columns, typically foreign primary keys in the same or different table. They are also used for testing that a group of columns is a valid according to some structural definition to which it should adhere. Business rule screens: the most complex of the three tests. The test to see if data may be across multiple tables follow specific business rules. An example could be that if a customer is marked as a certain type of customer, the business rules that define this kind of customer should be adhered to. When a quality screen records an error, it can either stop the data flow process, send the faculty faulty data somewhere else than the target system, or tag the data. The latter option is considered the best solution because the first option requires that someone has to manually deal with the issue, check each time it occurs, and the second implies that data are missing from the target system integrity, and it is often unclear what should happen to this data. Data cleaning in data science: data cleanup is an integral component of data science, playing a fundamental role in ensuring the accuracy and reliability of datasets. In the field of data science, where insights and predictions are drawn from vast and complex datasets, the quality of the input data significantly influences the validity of analytical results. Data cleaning involves the systematic identification and correction of errors, inconsistencies, and inaccuracies within a dataset, encompassing tasks such as handling missing values, removing duplicates, and addressing outliers. This meticulous process is essential for enhancing the integrity of analysis, promoting more accurate modeling, and ultimately facilitating informed decision making based on trustworthy and highly quality data. Steps to perform data cleanliness, that is removal of unwanted observations, fixing structural errors, managing unwanted outliers, and handling missing data. This is the total overall cycle which is connected to each other. Removal of unwanted observations, identifying and eliminate irrelevant or redundant observations from the dataset. The step involves scrutinizing data entries for duplicate records, irrelevant information, or data points that do not contribute meaningfully to the analysis. Removing unwanted observations streamlines the dataset, reducing noise and improving the overall quality. Fixing structural errors, address structural issues in the dataset, such as inconsistencies in data formats, naming conventions, or various tables, variable types. Standardize formats, correct naming discrepancies, and ensure uniformity in data representation. Fixing structure errors, enhancing data consistency, and facilitates accurate analysis and interpretation. Managing unwanted outliers, identifying and manage outliers, which are data points significantly deviating from the norm. Depending on the context, decide whether to remove outliers or transforms them to minimize their impact on analysis. Managing outliers is crucial for obtaining more accurate and reliable insights from the data. Handling missing data, devise strategies to handle the missing data effectively. This may involve imputing missing values based on statistical methods, removing records with missing values, or employing advanced imputation techniques. Handling missing data ensures a more complete dataset, preventing biases and maintaining the integrity of analysis. We have some pictures below, that is about the animation pictures of data cleaning and some other sources. Yeah, I hope you will understand and you will get something from me about the process of data cleaning in data management and representation concept. Thank you so much. Represented by Tarun Gaud Muddam from Data Science. Our roll number 22951A67F5.